Hello guys, let's start with another problem which is known as find pivot index. So what we are given? We are given an array of integer nums and we have to calculate pivot index of this array. So what is pivot index? Pivot index is the index where the sum of all the numbers is strictly to the left of the individual is equal to the sum of all the numbers strictly to the right of the individual. The pivot index is that the right side of the array's sum is equal to the left side of the array's sum at that particular index. If we find out that index, that index is known as the pivot index. Otherwise, we have to return -1. Here, the pivot index should that we return should start from the leftmost side. Okay. For example, we are given array nums this. Let's check the example. Okay, and let's take left sum and here take right sum. Okay, if you see clearly now, if I'll talk about the left sum, that if we start from the left index and start that what would be the count, what would be the increment count, like if we'll take another array as left sum and if we'll calculate from the left hand side the prefix sum of the array, what would it would be? So it would be 1 for the first index. It would be the nums of 0th only 1. Then for nums of 2 it would be nums of 1 plus nums of 2, that is left sum of 0 plus plus nums of 1. So it would be 1 plus 7 1 plus 7 1 plus 7, that is 8. So it would be 8. Then left of 2 it would be 1 plus 7 plus 3, that is 8 plus 3 is equals to 11. Then left sum of third is equals to 11 plus 6, that is 17. And left sum of 4 is equals to 17 plus 5, that is 22. And left sum of 5, that is the last index, that is 22 plus 6 is equals to 28. Correct? What about the right sum array? That would be our suffix sum. So we'll start from back side. So what it would be at the back, nums of n-1 would be right sum of n-1 is equals to nums of n-1. That is the rule, because we are starting from the right hand side of the array. The sum is starting from the right hand side. The first index would be equals to the nums of that particular index only. Okay, so right sum of n-1 is equals to the nums of n-1. So here it is equals to 6. Okay, then 6 plus 5 is equals to 11. Got it? Then 11 plus 6 is equals to 18. Then 18 plus 3 is equals to 21. Then 21 plus 7 is equals to 28. Then it is 6, so it would be equals to 17. So it would be equals to 20, my mistake, and it would be equals to 27. And 27 plus 1 is equals to 28. Okay, that's it. This is our count. If I'll talk about the indexing, what would be the indexing here? So it would be 0, then 1, then 2, then 3, then 4, then 5. Correct? So if you see clearly, we can see that if we'll add 1, 7 and 3, we'll get 11. And at the index 2, if we'll add 5 and 6 and 5, we'll get 11. Both are exactly correct. So what would be our pivot index? Our pivot index from the left sum array would be, because we want leftmost pivot index, it would be 3. That's what we have to return. We have to return our pivot index. Got it? What would be our logic? Simple. Prefix sum and suffix sum, and compare both these two. At last, we have to compare it in such a way that we'll return the leftmost pivot index. The simplest way to do is that we will make left sum array and the right sum array. And as soon as both the sum matches, we'll return the left sum array index. Correct? Correct, guys. It is the correct approach. Let's try to do it. So let's first calculate the length of the array nums. Let's take the right sum array of size n. If we are talking about the right sum array, so in right sum array, the last index would be equal to the nums of the last index. Okay, so right sum, right sum of n minus 1 should be equals to nums of n minus 1. Correct? Let's try to fill our right sum array. Int I is equals to n minus 2, as we have to fill from the rightmost side till I is greater than equals to 0, I minus minus. What would be the logic to fill the right sum array? That is nums of I plus right sum of I plus 1. Okay, let's take a left sum variable. Why we are taking left sum variable? Because instead of using left sum and right sum array both, I am using only right sum array and a left sum variable. Because here in this loop, instead of only storing the left sum array's value at that particular index and then again using a for loop to compare both the left sum and right sum index sum on which they both matches, I'll do both work here only. See how. I'll use a for loop, simple for loop in a forward direction from 0 to n. I'll take my left sum variable and increment it while adding the nums of I into the left sum, and then I'll compare that if my left sum is equals to the right sum of I. If it is equals to the right sum of I, then I'll return I. Otherwise, I'll return minus 1. That's it. Here, you can see while adding 4 and 5, I was getting 11. While adding 0, 1 and 2, I was getting 11. So my pivot index was 3. Got it? My pivot index was 3. That is correct. Leftmost side. This is what we are doing. We are comparing from the left sum array we are comparing from the right sum array our left sum variable, and if they both matches at particular time of interval, then we are returning that indexed I. Otherwise we are returning -1. It's just that I am not using left sum array, because again I will make left sum array here in this for loop, and in another for loop I'll compare both the left sum and right sum arrays. That is waste of time. Instead of that, I can directly compare the right sum array with my left sum variable, because it is moving in the forward direction and we need to return left moved pivot index. Okay, so it would be very easy. Let's try to run it. It will save our time as well, correct? See, it is working absolutely fine. We are getting 3 as a pivot element. We are getting -1 because all are in increment order. It is not possible that we can get the pivot element here. Here 2 is the pivot, first one is the pivot element. Got it? Let's try to submit it. Yeah, it is working absolutely fine. So guys, what could be the time and space complexity? As we can see, time complexity is big O of n plus big O of n. Why? Because we are using for loops 2 times. Correct? We are using for loops 2 times. One here to make the right sum array, and one here to get the value of left sum at each index of the nums, and to compare it with the right sum array. Okay? So we are using 2 for loop. Hence the time complexity is big O of n. What about the space complexity? Because the space complexity is also big O of n, because we are making right sum array of size n. So the space complexity is also big O of n. Guys, try to solve this question in such a approach so that the space complexity becomes constant, that is big O of 1. Try to think about that. There is no need to use right sum array and left sum array. I have shown you a way that you can skip for the left sum array. There is one way also that you can skip the right sum array as well as. Try to think about that approach and try to implement it. You can get through it through using the chat GPT or some other AI tools, but I recommend you first of all do some brainstorming, and then if you do not get into any conclusion, then you can use some AI tools like chat GPT, Google Gemini or something like that, or some other YouTube videos. But first of all, try to do it by yourself. And once again, please watch my videos, like and subscribe. And guys, please, if you are watching my whole videos, solve the quiz also at the last, so that I can get an evaluation how many of you are able to understand the solution which I am telling you guys. Apart from that, happy Holika Dahan to all. Thank you. Bye bye.